Welcome Wildcats. Today we're going to be looking at the 4.7 HRW assignment. You should have already taken the notes for that. That's finding complex solutions of polynomial equations. But let's go ahead and hop right into the HRW assignment. Most of these problems are relatively straightforward. So in this case it's asking us to find all the zeros of the given polynomial equation. They want us to include any multiplicities greater than 1. So what that means is, remember, a multiplicity is just another term for a repeated zero. So if it crosses at a specific place more than once, they want to know that. However, as I said, we are going to be using Desmos or whatever your graphing tool of choice is quite a bit. So I'm going to go ahead and pull up Desmos here. And what I can see is I've already graphed this one, 3x cubed minus 10x squared plus 10x minus 4. And looking at this, I can see that it does indeed cross the x-axis somewhere that I can see it easily. In this case, it's at 2. Our x value is 2. So we know that 2 is going to be one of our zeros. So we'll go ahead and plug that in here. Do keep in mind, though, that we have already mentioned that you're also going to have to use synthetic division. So I'm going to go ahead and write down this equation as soon as I find where there it is. Write down this equation. We have 3x cubed minus 10x squared plus 10x minus 4. So let's go ahead and go over to .cam. Alright, so here we know that 2 is one of our zeros. So we need to use synthetic division. 3, negative 10, 10, negative 4. And 2 is the 0, so we drop down the 3, 6, negative 4, negative 8, 2, 4, 0. So we know that we're going to have 3x squared minus 4x plus 2. 3x squared minus 4x plus 2. Remember, from here we're going to have to use the quadratic formula. That's negative b plus or minus the square root of b squared minus 4ac over 2a. A, b, c. The coefficient of x squared is 3, so that's our a. Coefficient of x is negative 4, so that's our b. Coefficient of c is 2. Negative 3, negative 4, and 2. So negative b becomes negative negative 4 plus or minus b is negative 4 squared minus 4 times a, which is 3, times 2, which is c. Sorry, times c, which is 2. All over 2 times 3, which is 6. So we have 4 plus or minus square root of 16 minus 24 over 6. 16 minus 24 is negative 8. Negative 8, we know that because it's negative we're going to have an I, and the square root of 8 is 2 times 2 times 2, so that's 3 2's. We can pull 2 of them out, leaving 1 on the inside. 4, 2, and 6 all share a 2, so divide each of those by 2. You get 2 plus or minus I root 2 over 3. So 2 plus or minus I root 2 over 3. So let's go ahead and go back to HRW. 2 plus, well, this is a fraction, oops, that first one was 2. And then we're going to have a fraction, and this is 2 plus I square root of 2 over 3 and fraction 2 minus I square root of 2 over 3. Moving on to number 2. Find all zeros. Basically it's the same question, so let's go ahead and go over to Desmos. And we have x cubed minus 4x squared cubed squared, there we go, plus 4x minus 16. So it looks like this one crosses at 4. So we know one of our zeros is 4. Using synthetic division, we take the coefficients. X cubed becomes 1. Negative 4x squared is negative 4. 4x is 4. And negative 16. Take the 4. We drop down the 1. 1 times 4 is 4. Becomes 0. 0 times 4 is 0. 4 drops down. And we get 4 times 4 is 16. Negative 16 plus 16 is 0. Once again we have a 0. But this time we have x squared plus 4. So that becomes our other factor, x squared plus 4. Well, that would be the same as saying x squared plus 0x plus 4. And we can still use the quadratic formula for this. So a equals 1, b equals 0, and c equals 4. Quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So plugging this in, b is 0, so you have negative 0 plus or minus square root of 0 squared minus 4 times 1 times 4 all over 2 times 1. Well, 0 is just 0, so that becomes plus or minus. 0 squared is just 0, minus 4 times 4 is 16. So plus or minus the square root of negative 16 over, and I'm sorry, this a should have been replaced with a 1. 2 times 1 is 2. Square root of 16 is 4, so the square root of negative 16 is 4i. Positive or negative over 2. 4 divided by 2 is 2. So we have plus or minus 2i. So that means we'll just put in 2i, and we'll put in negative 2i. Once again, same basic question, so let's graph it. X cubed minus 5x squared plus 8x minus 20 3x cubed minus 5x squared plus 8x minus 20. So this crosses at 2.5. So that means one of my roots is 2.5. So I have my coefficients are 2, -5, 8, -20. 2.5 is what we're multiplying by. Drop down the 2. Drop down the 2. 2 times 2.5 is 5. That's 0. Bring up the 0. Drop that down. Now 8 times 2 is 16. And another half of 8 would be 4. And 16 plus 4 is 20. Drop that straight down. And we get 0. That's supposed to be an 8. So we have 2x squared plus 8. Well, we know that a 2 factors out of that, so what we actually have is x squared plus 4. And we just had x squared plus 4. And we know that the roots of x squared plus 4 so if I were smart, what I would have done is I would have factored the 2 out of, oh, you can't factor a 2 out of here first. But once you do the division, you can. But we know that x squared plus 4 becomes plus or minus 4i. And this is 2 times that. No, it became plus or minus 2i, sorry. And this is 2 times that. So we're going to have 2i negative 2i. So make sure you factor that 2 out first and then do your quadratic formula. It'll be a lot easier. And remember quadratic formulas that you've seen in the past, because that will also make your life go a lot faster. Oh, I didn't guess that was correct. I'm sorry. 2.5, 2i, negative 2i is correct. So moving on to the next question. Again, very similar question, but this time we're actually going to have to factor out a couple of roots first. So let's go to Desmos. So we have x to the 4th minus 5x cubed plus 2x squared plus 2x. Alright, there are a couple ways that we can do this. The easiest way that we can do this is to recognize that because this crosses at 0, we can actually factor that out first. So we know that one of the roots is 0. And when we factor that out, let's go ahead and look at the cam real quick. So we had x to the 4th minus 5x cubed plus 2x squared plus 2x. We see that x is a common factor for all of them, so we can factor the x out first. So now we're just left with this. And looking at Desmos again, we see that 1 is actually a perfect root. So we're going to take 1 as our next root, and we'll go ahead and do the synthetic division there. So we have 1, negative 5, 2, 2, dividing by 1. 1 drops down, 1 times 1 is 1, negative 5 plus 1 is negative 4, negative 4 becomes negative 2, negative 2 goes to 0. So we end up with x squared minus 4x minus 2, x squared minus 4x minus 2, And now we have to use the quadratic formula to simplify this. So we have A is 1, B is -4, C is -2. Negative B, so negative, then B is -4, plus or minus the square root of B, -4 squared, minus 4 times A times C, -2, divided by 2 times A. So -4 is just 4, plus or minus the square root. -4 squared is 16. 4 times 2 is 8, so this is actually going to be plus 8. 4 times 2 is 8. Over 2. 16 plus 8 is 24. So 4 plus or minus square root of 24 over 2. Is take the prime factorization of it, you get 2, which is 12, 2, which is 6, 2, which is 3. So there are 2 2's, so I can pull one of them out. And what's left? 2 times 3, which is 6. This is going to be over 2. So that, and that all cancel. So 4 divided by 2 is 2, plus or minus root 6. Now do note that if we go back to Desmos real quick, you do actually see another place that it crosses here. And it's about 4.449. But they didn't ask us to get about what it equals. They asked what the solutions are. So in this case, all 4 roots are actually real roots. It's just that 2 of them, this -0.449 and this 4.449, are not rational. So we need to figure out exactly what they equal, which according to the math we just did was 2 plus the square root of 6 and 2 minus the square root of 6. So again, not complex, but not rational. So we had to find out the actual square root. Because if we'd have just gone like this, and we'd have tried to say, let's trash those answers. It was, oh, and I didn't show you that that previous one was correct. Anyways, let me just type in what they have here. They have -0.449, and they have 0, and they have 1, and they have 4.449. 4.449. So if I plug in all 4 of those, which is what they had, and I click check answer, it's going to tell us that one of them is wrong. At least one of them. But if I plug in the 0, let's just trash it. The 0, the 1, and then the 2 plus square root of x, which we found by doing the quadratic formula, and 2 minus the square root of 6, then it tells us that we're correct. So it wants an exact answer, not a decimal approximation. Height and trunk volume measurement. You guys can't actually read the whole problem, so let me fix that real quick. There we go. Height and trunk volume measurements from 10 giant sequoias between the heights of 220 and 275 feet in California give the following model. where h is the height in feet and v is the volume in cubic feet. The President Tree in the Giant Forest Grove in Sequoia National Park has a volume of 45,100 cubic feet. Use a graphing calculator to plot the function v of h and the constant function representing the volume of the President Tree together. Use this window, find the x-coordinate of the intersection of the graphs. What does this represent in the context of this situation? Okay. So, let's go ahead and graph these Desmos. You could use a graphing calculator if you wanted to. So we have 0.131 x cubed minus 90.9 x squared plus 21,200 x minus 1,627,400. And then we will change the axis to what they wanted us to, which they said 225 to 275. And 30,000 to 55,000 for y. Okay. And they want us to graph has a volume of 45,100. So, this is where they intersect. The x-coordinate of the intersection gives the model's predicted height for the President Tree. The intersection is at about x equals, what does that say? 265, 147. But they want it rounded to the nearest whole number, so 265. So basically all we had to do was graph the prediction that they gave us, graph the other line, find where they intersect, and all they want is the x value. So let's go to HRW. The x-coordinate of the intersection gives the model's predicted height, because this is height, for the President Tree. The intersection is at 265. Two competing stores, Store A and Store B, open in the same year in the same neighborhood. Annual revenue for each store T years after opening can be approximated by these polynomial models. Using a graphing calculator, graph the models from T equals 0 to 10 with a range of 0 to 2. Find the x-coordinate of the intersection of the graphs and interpret the graphs. Okay. So once again, we'll Desmos this up. So the first one is 0.0001 times negative x raised to the fourth power plus 12x raised to the third power minus 77x squared plus 600t plus 14,650. And then our second one, oh, I put t there. I've been using x. Go away. All right, 0.001 times negative x to the fourth plus 36t cubed minus 509t squared plus 3,684x. These are all supposed to be x's. Stop it. X, 3,864 plus 4,390. Alright, once again they tell us to change our scale. They say use t, which is our x-axis, from 0 to 10. And they recommend 0 to 2 for our y-axis, which they're calling r. Oh, I missed a 0. That explains it. Okay. 0. 2, 0 to 10. All right. Functions intersect at x equals 9, which corresponds to the number of years after the store is open when store B has the same annual revenue as store A. So we said the functions intersected at x equals 9. So say two stores open in 1990, then in 1999 they're going to have the same annual revenue, and after that store B would actually have more revenue. Number 7. Retirement account contains cash and stock in a company. Cash amount is added to each week by the same amount until week 33, then that same amount is withdrawn. The function shown model the balance B over the course of the past year with t time in weeks. Graphing calculator graph both models. Use this for the range. Find the x-coordinate of any points of intersection, then complete the interpretation of the results in the context of this situation. So as you guys can see, there are a lot of actual real-world applications for this. Whether or not you would personally use them in the future is a different story. But, I mean, we've got a lot of applications here that we're talking about. So, our two models are negative 0.12 absolute value of x minus 33 plus 14. And the other one is 0.1234 zeros and then a 5 times x to the 4th minus 0.00485 x to the 3rd plus 0.1395 x squared minus 1.135 x plus 15.75. And once again, they've told us to change our scale for x-axis. For range, they tell us to use 0 to 20. For x-axis, they really didn't specify, so I usually use negative 10 to 10. However, using this as our range, we can see that this goes down to here, and then it starts going up. And it becomes pretty clear that there is a point that they cross because this is cubic. Alright. Use a graphic calculator, graph most models. The graph intersects at x values of about. It crosses more than once. Enter the x-coordinate of the intersection to the nearest whole number. So, our first whole number is going to be 35. Second whole number is going to be 48. This means that those weeks of the year the cash balance is equal to the stock balance in the account. Boom. Done. Correct. Solve the polynomial equation by finding all roots. This is the same as what we've done, except now instead of having to type them in, you guys just have to click the ones that are roots, so I'll let you do that on your own. Polynomial equation by finding all roots. This one is a little different because you're not actually going to have to graph this one first. Keep in mind that 27, x cubed, and 64 are all perfect cubes. So because they're all perfect cubes, we can actually use the difference of cubes formula here. So 27 is 3 cubed, so you've got a equals 3x, and this is supposed to be 64, which is 4 cubed, so b equals 4. And remember, the difference of cubes formula is a minus b times a squared plus ab plus b squared. So plugging this in, I get a, which is 3x, minus b, which is 4. And then I get a squared, so 9x squared, AB, 3 times 4 is 12x plus 16. Now in the past we always left it here because there was nothing else we could do with it. However, now we've learned that if we take this and use the quadratic formula, we get even further. We do have our first root already though. Our first root is going to be 3x minus 4 equals 0. So 3x equals 4. So x equals 4 over 3. So I'm going to go ahead and put that in now. Now this is going to be a little bit interesting because this gives us an a value of 9, a b value of 12, and a c value of 16. So let's go ahead and see what we can do here. Negative 12 plus or minus square root 12 squared minus 4 times 9 times 16 all over 2 times 9. So that's negative 12 plus or minus the square root. 12 squared is 144. 4 times 9 is 36. 16 times 36, that's 36, that's 18, 19, 20, 21. That's 216 plus 360, which is 576 over 18. 576, 144 is 2. 3 is 4, so that's negative 12 plus or minus the square root of negative 432 over 18. 432 divided by 2 is 216, divided by 2 is 108, divided by 2 is 54. Divided by 2 is 27, divided by 3 is 9, divided by 3 is 3. So I've got 2 pairs of 2's and a pair of 3's, so that's 2 times 4 is 12. So this is negative 12 plus or minus, that's 2 times 2, 2 times 2, 3 times 3, so that's 12i, and then all that was left was a lonely little 3. So 12i square root of 3 over 18. 18 and 12, they both share factors of 2, so this can become negative 6 plus or minus 6i over 9. They both share 3, so this can become negative 2 plus or minus 2i over 3. So negative 2 plus or minus 2i over 3. Negative 2, let's put this in a fraction first. Fraction, not there. Fraction, negative 2 plus or minus 2i over 3. Did I do something wrong? 27x cubed minus 64. No, 4/3 is correct. And 2 plus or minus 2i over 3 should be correct. X squared plus 12x plus 16. Negative b plus or minus square root of b squared minus 4ac over 2a. Negative b is negative 12 plus or minus 12 squared minus 4 times 9 times 16 over 2 times 9. So that's negative 12 plus or minus the square root. I know 12 squared is 144, but let's double check. 4 times 9 times 16 is 576. 2 times 9 is 18. Let's check 144 minus 576 is 432. So this is negative 12 plus or minus the square root of negative 432 over 18. 432 divided by 2 is 216. 216 divided by 2 is 108. 108 divided by 2 is 54. 54 divided by 2 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. Okay, so that gives us 1, 2, 3, 4 2's. So that's negative 12 plus or minus square root of negative 2 to the 4th times 3 cubed over 18. Well, 2 to the 4th means I can pull 4 out. Negative 12 plus or minus. That's a 4 I can pull out, and that's a 3 I can pull out. And the negative means I can pull out an I. And all that's left on the inside is a 3. Negative 12 plus or minus 12 I root 3. I forgot the root 3. That's all I did. When I was plugging it into HRW, I had done the math correctly. I had just forgotten to plug in the root 3 in my answer. That's all. That's all I did. So it's negative 2 plus or minus 2i root 3 over 3. Next! Oh, forget I did that one. So then solve the equation by finding our roots. Exact same thing we've been doing. And those are the 10 questions on this assignment. I did not realize that, but apparently this assignment only has 10 questions. So with that, guys, buena suerte!